next algorithm for today is to check the sum of all prime numbers. What is prime number? Actually, this prime number is a number can be divided by himself and 1 also. For example, 7. 7 is prime number. You can divide 7 for any other numbers than himself and 1. 8 is not a prime number. You can divide 8 by 4 or also by 2. And so our first step, we want to check if we want to check the prime number below a given number. Our second step, we want to add these numbers and get the sum of all these prime numbers. How to do that? Let's start with our pseudocode at first. So in the pseudocode, I want to define a function text number as a parameter. Okay. And then I want a variable to hold the sum of these values. So I define variable to hold the sum of the numbers. Now I want two for loops, one responsible for the sum and one responsible to do the divisions and make sure that the number is prime or not. So first I need for loop start from the given number and it's going to end at 2. Okay. Why? Because we are going to sum all the prime numbers, like I said, but 1 without 1 and 0. So the loops will start as a given number and end at 2. Then I want also to define a variable to help me determine if the number is prime or not. Okay. Okay, let's keep it like this for now. Then I want a for loop to do the divisions. Start from number -1 and also it will mean 2. Because like I said, also even the prime numbers can be divided by 1. So if it's end at 1, then I'll get a wrong result. Okay, so now what to do? Now I need the condition. Condition to check the remainder, the remain of the division. And determine if the number is prime or not. So if this condition true, then the number is not prime. Nothing is going to happen. I'll start another loop. Okay. Start another for loop. Okay, and if this condition false, which means there is no remain and the number is prime, I want also a condition. So the condition to check if the number is prime and to sum it. Then sum. At least I will be given the sum. Okay, let's start the code in the function. Let's call it sum primes. We'll take a number as a parameter. I need a variable to hold the sum value. For me, it will be 0, not 9. Okay. Then a for loop. If I equal to the given number and I is bigger or equal to 2, I minus 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 minus, yeah. And then let is prime equal to true. Another for loop going to start from I minus 1 because I'm going to divide the number by all the numbers beneath it. If I divide it by itself, so of course there will be no remain and I'll get a wrong result. And sorry, j is bigger or equal to, yes, equal to 2 and then j plus plus, sorry, minus minus. Now I will put the first condition. If the remain of the division of I and j equal to 0, then this number is not a prime. I will set the variable is prime to be false. And then I will break the for loop because I have already get the result as the number is not prime. And so, and so, and so. And when the for loop is, this for loop is finished, and I didn't set its prime value to be false, then it's a prime, the number we have is a prime number. And yes, now I want to condition to make sure that the number is prime. So if is prime equal to true, sum plus equal to sum, and so and so and so on. When I finish, I want to return sum. So let's run our code and check the reason. Of course, there will be no result because I forget to console log and call our function. Some primes exactly. I will pass them. I think it must be 17. The result must be 17, 0, which means there's something wrong. Let's check again. Sum starting from 0 and I equal to num I plus plus. Yeah, that's true. It is prime is equal to true if it's prime equal to if the number is divisible, there's no remain. Is prime equal to false and break? Yes, that's right. And here, sum plus equal to, okay, this is a mistake I made. Sum plus equal to I. Yeah, now it's working. So, in a brief function, take number as a parameter. First for loop, responsible for the sum. The second for loop, it's responsible to make the divisions and to check if the number is prime or not. I need a condition to do that. And so, let's go to the T diagram. Let me just make it more clear. Okay, yeah, here it is. Delete this field, delete this field, and also this one. Yeah, that's great. And yeah, clear this one and this one. Let's start with index I, then index j, condition, and the second condition, and the result. So when I equal to the given number, which is in our case 10. So now we'll start j now equal to 9. Okay, and if the 0 remain, equal to 0. No, it doesn't equal to 0. If we divide 10 by 9, the remain is not equal to 0. That means this condition is false. And before I check the second condition and set a result, I have to finish the whole this loop. Why? Because this condition is out of this loop. So when I finish this loop, okay, I get the result and then I will check this condition and make the changes to sum. And now when j equal to 8, also it's false, and when j equal to 7, also it is false, and so, but when j equal to 5, it's true, which means now is prime is false. Now we will break this loop, and at this point, I'm going to check the second condition. Is prime is true? It's the value of it is true, not false. This means this condition is false. The result, nothing is going to happen. And now I equal to 9, and so and so and so. I hope that was clear for you, and that's all.